Okay, so our learning goal today is that you could graph a linear inequality in two variables and to show its solution. And the reason that we have to show the solution, we have to solve these by using a graph is because there's an infinite number of solutions. We can't begin to list all of them, so we have to be able to, so we show it with a graph. Okay, so let me take a moment to calibrate this since it's not acting like it likes me at the moment. Okay, so to graph a linear inequality in two variables, the first thing we're going to do is we're going to graph the boundary line. Okay, so we have to create a line on there. So we have these linear inequalities that the boundary line should be a straight line. We're going to make it a solid one if so. How many inequality symbols do we have? How many different inequality symbols are there, by the way, Cody? 4. There's actually 5, but one of them we're not going to use right now. It's the is not equal to. That's considered an inequality symbol also, but what we have the other 4. So which one or ones would indicate to us that we should have a solid boundary line? Noah?
The one that has the line on top.
Okay, so what? Say those for me.
The less than or equal to.
Okay, is less than or equal to, or is greater than or equal to. So in other words, the two inequality symbols that have the equal to bar as part of them, the is less than or equal to, or is greater than or equal to. If you have one of those symbols in your inequality statement, you know you have to make a solid boundary line. Well, then we make a dash if what? Which inequality symbols would indicate a dashed boundary line? Abby? Is less than or is greater than. Those two inequality symbols would indicate a dashed boundary line. In other words, we dash it because none of those points on that boundary line get to count as a solution. So by leaving gaps in the line, we're showing, you know what, none of the points on this line are considered a solution because the line itself, all the points on the line itself satisfy the equal to part of the solid ones. So we're going to shade the graph above or below. Now, you did test points. Did anybody discover when it turned out that you were shading above the line? What did the inequality symbol have in it that turned out the shading ended up above the line? Cody?
When it was greater than or less than, or when you picked your test, your point that was greater than or greater than your equation.
Okay, so if it had an is greater than symbol in it, it tended to be shaded above. Okay, anybody else discover that's what happened? So think about is greater than. So if we take the number line and we have it vertical like a thermometer is, when you think about the temperature getting greater, which direction are you going?
Right.
It's rising, you're going up, aren't you? You're going in the above direction. So that is exactly what happens. When you have an is greater than, it should turn out, when you do your test point, it should turn out that the shading ends up above the boundary line. And then we could say or, if it has that symbol, because that also has the is greater than part. It's the is greater than part of the symbol that ends up having it be shaded above. Or in other words, the is greater than part, the shaded part is where a whole bunch of the solutions also reside. And then we shade below if what symbols are in our inequality statement?
Less than or less than equal to.
Is less than. So below, if the temperature gets less than it was, it decreases, it goes down. So is less than or is less than or equal to. Either of those symbols would indicate that you should shade below your boundary line. Okay, well then we test a point. Now, don't ever test a point on the boundary line. That's not going to help you with the shading part. That's only going to tell you whether your line should be solid or it's going to be dashed. And we're going to feel pretty confident about our line being solid or dashed according to the equal to bar being part of it. Okay? We're not going to test our boundary line. You can if you want, but just know if you're going to pick a test point from the boundary line, you're testing the boundary line. You're testing if the line should be solid or it should be dashed. True would be solid, false would be dashed. But we're not testing that, we're testing to see where we should shade. So when we test a point, we're going to pick one that's not on the boundary line. If the point is in the shaded half plane, in other words, it's not shaded yet, but if it should be in the shaded half plane, it should make the inequality true. So the point that you pick, if it makes the inequality true, you know it comes from the shaded half plane. So shade that side. If it makes the inequality false, then it better be residing in the unshaded half plane. So if your test point makes the inequality false, it better be hanging out on the unshaded side, the unshaded half plane. Okay, so those are all the things that set us up for being able to show the solution on a graph correctly. Okay, let's practice this one. Negative 2x plus 3y is less than negative 15. Why do I say put it in slope-intercept form?
Because you only get one of the variables.
Yeah, that's the standard form. Can we get the slope and the y-intercept from standard form?
No.
No, don't try. Don't say that the slope for this one is negative 2 and that the y-intercept is 3 because it's in standard form. So we're going to first put it into slope-intercept form. And we're going to leave the inequality symbol in it because does anybody remember there's a certain rule for when you're solving inequalities? When you multiply or divide by a negative number, what has to happen?
Your inequality has to change.
It has to reverse, doesn't it? Remember back last year when we were solving inequalities with one variable, they said one variable in there. When we were solving inequalities with one variable in it, if we would multiply or divide by a negative, we had to reverse the symbol. Whatever, if it was is greater than, it had to become is less than. If it was is less than, it had to become is greater than. So we have to keep that in mind when we're getting this in slope-intercept form also. So what would be our first move here? What would be our first move here? Aurora. Abby. Get X along? Get Y along. So what would be our first move here? Add 2X. Uh-oh. Brain freeze. So now it reads what?
3y is less than negative 15 plus 2x.
Okay. Do we need to reverse that symbol?
No.
Do we multiply or divide by a negative?
No.
No? Okay. What's our next move then?
Divide both sides by 3.
Divide each piece
Individual.
by 3, right? So 3y gets divided by 3 is less than negative 15 gets divided by 3 plus 2x gets divided by 3. And now our inequality reads,
Y is less than negative 5.
do we need to reverse the symbol?
No.
Because what?
Because you multiply by
We didn't multiply by anything.
Oh, you divided by a positive.
We're dividing by a positive 3, so we do not need to reverse the symbol. We can leave it the way it is. And negative 15 divided by 3 is? Negative 5. And 2x divided by 3 is? 2/3 x, right? Okay. We got lots to do in this white space here, so I hope you're not writing too terribly big. Because now we know that we need to put our first point where?
At negative 5.
At negative 5. So we're going to go to our graph and put our first point at negative 5. This is our B value, right? And what's our M value? I'm hoping that we're ready to do this graphing without writing everything down. 2/3, so we can go
Up to right 3 or down to left 3.
okay. Good boundary lines come from lots of points. Next decision we have to make is should it be solid or should it be dashed?
Oh,
Dashed. Why should it be dashed?
because
Because it doesn't have the equal to bars. So take your ruler now and make a dashed boundary line. Once we have our boundary line graphed, we have to pick a point not on that boundary line and test it. Now, anybody want to predict according to the symbol where you think the shaded region would be? Would it be above up here, or do you think it's going to be down here below? Because why? Because it is less than. So let's pick a point from that region then, okay? Let's see if it makes it true then. So pick a point. Not on the boundary line.
Negative, or 3, -6.
So right here, this is our test point. Whoops, I need to, oh, I lost it. 1, 2, 3, 1. It's good to put that point there, you know, so that you can see where you were testing. So we're going to test 3, -6. That's the point that we're going to test. 3, order pair 3, -6, because we think it should be shaded below. So this one should make it what? True or false?
True.
Should make it true. Okay, so we're going to substitute in negative. We're going to go back. Remember, this is kind of like a check problem. We're going to go back and do it in the original, because just in case we renamed it wrong, remember that? We can very easily rename them incorrectly. So let's go back up here to our -2x plus 3y is less than -15. And sub our x and y value into it. Okay, -2 times 3 is? -6. 3 times -6 is? -18. -6 plus -18.
-24.
-24. We evaluate this statement and say true or false. Is -24 less than -15?
Yes.
Okay, so this is a true statement. So we just verified that that point should be where? On the shaded side. So now we're going to take our pencil and we're going to shade that side of our coordinate line. So very quickly, without thinking very hard at all, name one solution of this.
-2.
Oh, no. Everybody, very quickly. No.
-6.
No.
I mean, 4
By
-6.
the way, no, thank you. 3 -6. We just tested it. It's a solution, right? I didn't want you to think very hard. Then I'm going to guess that all those other ones you were naming were coming from the shaded region also, weren't they? Yeah. Can we name a point that's on the boundary line and call it a solution?
No,
Why not?
because it's a dotted line.
It's a dotted line, it's a dashed line, and it does not include solutions. So anything on the dotted line and anything above the line is considered a non-solution. Anything in this shaded region is considered a solution. So there are an infinite number of solutions. We can name ordered pairs forever, but there are also an infinite number of non-solutions. So if I asked you to name those, you could also name a whole bunch of those, right? Okay, anybody have questions? Okay, let's go to the back side then and try one more together. Okay, you go ahead and get this one put into the slope-intercept form first, and then stop after that. If we need to, I think some of us still correct our mistakes we're making there. Well, the first thing I did is I changed it to from being a subtraction problem to an addition problem. That's my first red line there. Then I'm starting to solve it after that, or solve it. Trying to get it in slope-intercept form after that. I'm working on my steps to get y alone. Well, then I decided, you know what, here's another spot where there was subtraction, so I changed it to add the opposite to help me be more successful. And then I'm now dividing everything by -15, and my intercept form is that. Do you agree with me?
No,
Why not?
because you have to change your sign.
Oh, I have to flip the sign because why?
Because you divide by a negative number.
Because we divide by a negative, and when we divide by a negative, we have to make sure that we remember to reverse the symbol. So from it being is less than or equal to, it has to switch to is greater than or equal to. So the arrow part of it reverses, doesn't it? Okay, now, what's our M and what's our B?
M is 1 and B is 2.
M is 1, B is 2. Maybe we should write this down this time because some of us maybe didn't remember this so well. And then not only do we have to decide where and how we're going to make the points, but we also have to decide if our line should be solid or dashed.
Solid.
Why solid?
Because it has an equal sign on it.
So solid besides. Okay, so go ahead, graph your boundary line. Get your boundary line graph for this one. Again, we should still be asking ourselves the same question we've done every time we've graphed lines. If I have a positive slope, my line should be doing what?
Rising from left to right.
Rising from left to right. Your boundary line should go all the way through your graph, not just through the 3 points you made or whatever. Okay? Make a decision. Do you think you should shade above or below? Above. Well, where is above on this one? Left or right?
Left.
Left. Okay, so we want to pick a point from that region?
Yes.
Okay, so we pick a point from that region. Everybody pick their own point. Pick a point. Pick your own point from that region above the line. Pick your own test point. Can it come from the boundary line?
Yes.
No, it can't, but if you do, are you checking for shading then?
No.
No, you would be checking to see if the line should be solid or not. And that's what we want to know. We want to know if we're shading the correct side or not. So here's where we think it should be shaded. Don't shade it yet, but pick a point from that region somewhere. Pick your own test point. Put it on the graph and test it. Write it down. What's your ordered pair you're testing? And then test it out. Where should you test it at?
In the original
In the
problem.
original inequality statement. Don't test it in your renamed because you might have named it wrong. You'll eventually get smart enough to pick points that have zeros in them. You can. They could both be zeros, or they could one of them be zero. It actually makes it a little bit easier. You don't have to take all that calculator so much. I ended up with a true statement. -60 is less than or equal to -30. It's less than -30, so it meets that standard. So my ordered pair, 0, 4, which is up there above the boundary line on the y-axis. Test true. Is this test true?
Yes.
Can anybody think of a test point that you could actually use every single time if you did not care whether it came out true or false, because you would know what to do? 0, 0. Could you test the origin as long as what?
It's in the shaded.
No, as long as it's not on the boundary line. So if we would have tested 0, 0 here, let me just show you what happens when you get to test a point, the origin, and it's not on the boundary line. My favorite test point is the origin, because when you multiply by 0, what do you get?
0.
0. So when I have that 15x, I'm taking 15 times 0 minus 15y, I'm taking 15 times 0 is less than or equal to negative 30. I do not need my calculator. 0, take away 0. What is 0 take away 0?
0.
0. Now, here's the thing that might trip you up, but it shouldn't have to. Is this a true statement?
No.
Is 0 less than negative 30? No, it's greater than, isn't it? So this is
False.
false. If it's false, what does that tell me?
Shade on the opposite side of the line.
Shade where the other side, where this point did not come from. So 0, 0 is not in our shaded region, is it? So it should test false. So sometimes you can just pick a point. You don't even have to decide, where do I think it should be shaded? You don't even have to go there right away. You can just say, oh, the origin is not on the boundary line. Yay, I love that test point. I'm going to test the origin. And then you test it and it turns out true. That tells me, oh, I better shade the region and turn then. If it tests false, that means I better shade the other side of the line. So then I go and shade, and then I say, you know what? Looking at my original statement is less than, that's telling me I should have shaded below. Why didn't we end up shading below?
Because 0 is greater than negative 30.
No, why? Because we ended up having to reverse the inequality symbol, didn't we? So see, sometimes you can't even count on it. You're like, uh-oh, this said is less than. That means I should be shading below. But we can't count on that. If we end up in the process of getting it ready to graph, we end up switching it around. So it's almost like this is where you got to decide, should it be shaded above or below? And remember, we did kind of make that decision at that point. We said now it should be shaded above. So the test point is very, very useful for, don't just count on the above and below thing. The test point should help you make the decision where the shaded region should be, and you need to use it, okay? Anybody have any questions? Don't put this away. This should be out to help you, guide you, and you need to have a sheet of paper and your book, because it's a book assignment, but I just had the Brent's handout. You know what? I might be wrong. You don't need a sheet of paper. I did it so that you could do it right on here. I take that back.